Good morning, everyone. Today we are going to discuss on the topic of sets and the maps. When we are already started with the collection concept, in the collection concept, we are left with the sets and the maps. Sets and maps are nothing but we already seen the list interface and the list interface types and stacks also we'll see it, queues also we'll see. This is one type of data structure. You have to understand the first what is the difference between such type of collection and the set. First, the set is nothing but it is a collection of elements like a list, but the major difference between a list and the set is set stores only the unique elements. That is the only difference between list and the set. Okay, first difference, the difference between the sets and the list is lists can store the duplicates also, and also you can access through the indexes, and it can dynamically resize and all the things. Sets also dynamically reset, but the difference is sets only stores the unique elements. Sets not allowed to store the duplicates. Okay, first thing new. Sets explanation first. Right, in that firstly the set is nothing but a set. It's better to use the comments and all the declaration what you are mentioning in a programming. You have to be right about it. Why? Because when you are dealing with the real world programming also, you have to mention the what the things you are used below, then you have to mention it as a comment of above. So it is, we are calling it as a documentation. In that firstly, suppose first the set is nothing but it is a collection of unique elements. Set is nothing but set is collection of unique element. That is the only difference between the your normal array list and stacks and the queues. That is a different approach. But array list and the set, the difference is it is the collection of unique elements. Okay, in the set, in general, set is a interface. Set int is a interface. We already saw the list interface, like that set is also a interface. So in the list interface concept, what the classes we are already seen: array list, vector, linked list, stack, queue, like that we see. Like that here also set is a interface. So for that set implementation also, there are the three types of sets we have. First one is hash set, second one is linked hash set, third one is tree set. These are the major sets we have to be known, and the implementation. These all are also the same. Set is nothing but it is a collection of unique elements. Then what is the difference between these three? Okay. Then what is the difference between these three? This is common for the entire set types. Collection of unique elements. It is same for the first, second, and the third. And what is the other than that? Hash set is a collection of unique element, not maintains the order or not guarantees the order. Not guarantee the order means, suppose you are first inserted the 10, after inserted the 20, we are not guarantee it was store 10 and 20. Maybe it will be stored as 20 and 10. That means suppose my insertion order is like a 10 and 20, but it will store like a 20 comma 10. I am storing my intent to store like this, then I am adding the elements in the way, but it was storing like this, not maintains the order, not maintains the order. Then through the indexes also you can't able to access it. Okay, why? Because how can you access through the indexes? It will maintain the, if it was maintaining the order, then you can through the indexes, index 0, index 1, index 2, index 3, like that you can access it. But we are not guarantee the order. Sometimes it will be in order, sometimes it not be in order, right? Sometimes it will be in order, sometimes it not be in order. So we can't access through the indexes, can't access through indexes. Why? Why? Because it was not guaranteed with the order, so we are not able to access the elements of a set through the index. Fine, right? If it will maintain the order, then you can simply know first element is 10, second element is 20, third element is suppose what you are inserted, fourth element is what you are inserted, but it will not maintain the order. Now then how can I know my first element is my inserted one, or second element is my inserted one? How can I know? So based on that, can't access through the indexes. Okay, right? First we see the differences of the all the sets, then all are the same. Now what is the other than that separate with the hash set and the linked hash set? Linked hash set not maintains the order, right? But linked hash set maintains the order. Why? How? Why? Because what means linked hash? That means linked list is nothing but every element storing it as a node and maintaining the links, right? Then linked hash set also same like that, but the condition is it stores the unique element. Linked hash set and linked list are the same, but the difference is storing the unique elements, storage of unique elements. That means not allows the duplicates. Then it will maintain the order. Now how can I say it will maintain the order? Means suppose every element can be stored it as a node. First every element store it as a node, from node to node it will maintain the links, right? In the set stores the unique elements, but it will maintain the links, right? That means first element to the second element it will maintain the link, second element to the third element it will maintain the link. Then means it will maintain the order. What was the first inserted, it will be stored at first. What will be the second inserted, it will be stored at second. What will be third inserted, it will be stored at the third. Suppose I have a one element. Okay, I have one element in my node 1 of element, and I have the other second element. Wait a minute. Suppose I have the other element, right? I have the third element. If it was a node of 10, it is the node of 10, it is of 20, it is of 1. Okay, it was stored at separate location of 1000 location, 100 location, it was at 90 location, it was at 145 location. Okay, randomly, right? My first element inserted is find the free space at 100 location, so insert the 10 element at the 100 location, 20 element at 90 location, for one element at 145 location, but it needs to maintain the insertion, right? That means suppose you want to maintain or access the next element, that means from first element to the second element you has to maintain some link. How it will maintain this 90 whatever it is, it will be stored in the address part of the data. Every node has some address part, so in that address part it will store the address. The same way this 20 element also store the address of 145. So obviously it will maintain the order, right? Obviously, it will maintain the order. That is the difference between normal hash set and the linked hash set. Hash set not maintains the order. That means not guarantees the order. I am not exactly saying not maintains the order. I am not guarantee. Sometimes it will maintain, sometimes it not. Okay, sometimes it will maintain, sometimes it not. So I am not guarantee with the order, but here I can guarantee with the order. That is the difference. And we already know hash set and hash list and all the list. It will be stored in a continuous memory location. Linked hash set stores in a random way. Guarantee the order of insertion. Okay, or order, guarantee the order of insertion or order. Okay, right, fine. Next, tree set. Tree is a normally data structure. It is a different data structure other than the linked list. How actually the tree lies is simply a simple tree is nothing but suppose it has a root element. From the root element to there are the multiple childs. We are calling it as a branches. Okay, multiple childs. It was one tree like this. From this to some branches will be evolved. This is one, this is one, like that. The tree is like this. Tree is a different data structure. There are the two, we are calling it as a unordered data or unordered data structures. Why? Because it doesn't have any order. That means here to from here to you can traverse to this side or you can traverse to this side. You don't know which side you can traverse. We are calling it as a unordered data structures. Normally ordered data structures, unordered data structures, there are the two types. Ordered data structures are nothing but linked lists. Those are comes under ordered data structures. These are comes under unordered data structures. These are entirely data structures concepts. Normally tree means like this. It has some different childs and all the things. But here your tree set stores the elements in a binary tree manner. That binary tree is nothing but how the binary tree actually is. Binary means 0, 1 or 2. That means it has two childs. We are suppose we are calling, we are at this mode. This is one child, this is one child. At most two childs, at most I am telling about. That means one child is enough, or no childs are also fine. At most two childs. Here we will see this node has three childs. It will not a binary tree. Here your tree set follows the binary tree structure. That means suppose I have a data of, wait a minute, I have a data of 10, 20, 30, sorry, 20, 30 and 40 suppose. Okay, this is the way my elements are there, or else it is a 50 and 40, right? This is the way. But your tree set, what it do is it will stores the unique elements but in a sorted order. Why it will stores in a sorted order? Because it will stores or it will maintains the binary tree. Binary tree, what it will do is binary tree actually stores the elements in a sorted order. Binary tree stores the elements in a sorted order. How can I say it is? Suppose 10 is the element. 10 is the element. First insertion element is 10. Then first element store is wait a minute. Suppose first insertion element is 10. Then 10 will be stored. Okay, 10 will be stored. It is one node. It is first root element was stored. After that I have a two options. One way this side and another way this side. Okay. Next 20 was inserted. If 20 was greater than the root, 20 is greater than the root, then it will inserted at the right side. 20 is greater than the root, then it will insert it at the right side to the current node. Actually we are comparing with the current node all the things. 20, right? And also 30, 30 is greater than 10 and also greater than 20. So for the 20 right side your 30 will be stored. Okay, from the 20 right side your 30 will be stored, right? Here it will store the 30. And next 50 is there. 10 greater than 50, 10 greater than 50 greater than 20, and also 50 greater than 30, right? So it will insert it at right side of 30, right side of 30, it will call as 50. Here it will insert at 50, 50. And next 40, 40 greater than 10, 40 greater than 20, and 40 greater than 30, but 40 not greater than 50. So it will insert it at the left side of the node. All the right side elements are the greater and all the left side elements are lesser than the current node. Suppose if we are if you are at this node, all the left side tree elements whatever it has, it all will be less than 10. From the right side elements all will be greater than 10. From this node also the same, from all the left are the small, right are the great. Like the way your tree set also stores that, your tree set also stores that. So all the elements stores in a sorted manner. Your tree set stores the elements in a sorted order, stores the elements in a sorted order, right? Then you can know which type of set you can use in what scenario, right? Suppose you have a case of you want to store the only unique elements and need to maintain the insertion order, then linked hash set is the best option. If not maintaining the order also the fine, then hash set will be the option. Suppose you want to store in the sorted manner, then tree set is the difference, then tree set is the option. This is the difference. If you know the difference, then you can easily understand in the scenario which type of set you can use. These are the three types of sets in the under set interface. Okay, right. Now we can see the implementation of the sets. First, how can I create a set? By using the set interface. Okay, by using the set interface you can store the set by, that means you have to store the only unique data types, then you can mention the data type, or else you are not mentioning the data, both will be fine. Suppose if I want to store the only the strings, set equals to new, by through the classes only I have to create a constructors, right? So I can use the hash set. First thing, these all are under the java.util package, so I can import java.util.star. Remember one thing, when you are writing the programming, never first import the statements according to your instructions or your steps of programming. You have to import the necessary packages. If you are directly import the packages, then someone who are interviewing, then they can understand you are by heart it, or you can copy from the others, like that. So the better way to write it is, when you have to import something, firstly you have to write it in the program, then only you can import it, right? This is a simple question. How can you know which can import at the first, right? Through the programming only you can know, you have to, you are need that package, or you can need the necessary details and all the things. So through when you are dealing with the steps of programming only you can understand, right? So then this is the basic sense. Then then interviewer can examine you, right? Set, this is the hash set. We already seen how can we add an element, right? Add an element in array list also. We can see how can we add an element. Dot add, right? Add of 10. Okay, sorry, I am taking the string data type and I am passing the integers. That is the case, right? And I am forget to tell one thing. Set can stores the nulls, okay? Nulls also. Fine. Okay, fine. Set dot add of 20. No, 0. Right? Fine. It's fine. Set dot add of null. Null. Sys out of set. Right? Okay. We already know set stores the only unique elements. What will be the case if I try to add the one duplicate also? Set dot add of again 10, right? Okay, fine. Again I'll try to add the null. Fine, fine, fine. Sys out of set. Sys out of set. Fine. I'll run this. 0, null, 10. But what the order I am inserting? 10, 0, null. It will store in an order of 0, null, 10. Okay, fine. If again I'll try to add this, then it will not throw any error and also not stop the execution flow. It will simply avoid the statement. Why? Because already the element is there, na? So because of that it will uh, not add it. But null, if I'll try to add the null, then it will stores the null. No, why? Already null is there, right? What actually null means? Null means null has no value, undefined value. Then null has no value, right? Then how can you take it as a duplicate? Null has no value. Suppose I'll make this into a another set of of string new linked hash set. Here only I can say linked hash set. Fine, fine. In the same way, we already see for the set, right? The same thing we can do for the set one. Instead of set, I'll go for the set one. Now you can observe the difference. Fine. It will maintain the order of insertion. It will maintain the order of insertion the same way. First I'll show the differences, right? Then we will see that what are the different methods we have. It will be fine. First we will need to see string set 3, set to new preset. Fine. Set to dot add of 0, set to dot, right, and I'll print the set to. Right. What was the tree set difference? We'll see. Tree set stores the elements in a sorted order, but these are the strings now. Then how it will be sorted? Through the alphabetical order, but it is not alphabets also. Null pointer exception. First thing, in the sets, in the tree set, these all elements are stored in a sorted order, so you can't use the nulls. First thing, you are not allowed to use the nulls. Why? Because why you are not allowed to use nulls? Null has no value. Null has no value. Then how it will be sorted? Then how it will be sorted? It will be the 0, or it will be the 1, or it will be the anything of the value. Then it will be sorted. It will be assigned in a position. It doesn't have any value. Then how can it sort it? So in a tree set, you are not allowed to use the nulls. This is the another difference with the tree set. Tree set not allows the nulls. Hash set and linked hash set allows the nulls. Tree set not allows the nulls. Fine. 0 and 10. Okay. In a sorted order of alphabetical order. In place of that, I'll go with the banana, apple, mango. Then it has to be, I am expecting the output of in the order of apple, banana, mango, right? In the alphabetical order, it will be sorted out. Suppose it was an integer, directly sorted out based on the values. It was an strings, then it will be what happened? Why? Because capital B, small a, right? We'll do one thing. Observe the difference, right? In before I am placed the small a. Normally alphabets are will be sorted in the order of ASCII values. ASCII value of 65 is capital A, 97 is small a, 66 is a capital B, 98 is small b. So capital B is in a sorted order rather than the small a, right? Suppose this is the case, so you have to be maintained when you are dealing with the programming. You have to be focused on some edge cases. These are like a edge cases. Suppose what will be the case? First letter is capital, one was capital, one was small, right? Then you can simply do the string methods of every string. You can convert it into the lowercase and the uppercase, either uppercase or in the lowercase. Then you can compare it. Right? That was the way of sorted. It will be stored. First, we'll observe the what are the differences between the three types of set interfaces, right? One will not maintain the order, one will maintain the order, one will in a sorted order and not accept the nulls, right? This is the major question when interviewer can ask, right? Suppose when you are give any statement, you have to be define it. This is the way you can define. Okay. Next, uh, all will be the same methods. So for a while, set 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 and set, right? This is the way of adding the elements, right? Then how can I remove the elements? Through the indexes I can't. Through the index I can't do anything. Why? Because it will not maintain the order, so through index I can't do anything. So how can I remove an element is based on the element. So set dot remove, set dot remove of suppose mango. Okay, I am my intent to remove the mango element. That means what was the element you have to remove or your intent to remove, then use that in the remove method. But suppose, okay, it will be work fine. We'll check that first. Fine, 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 fine. Right, removing the mango, apple, mango, banana. Has it now? Then not sorted order. It will be in a random way of order taking. Then mango will be removed. Then what will be the case? Suppose my intent to remove mango 1. My set not contains the mango 1, but I am my intent to remove mango 1. Then you can observe the output. It will not throw any error, but it will not simply remove it, not remove it. Why? Because mango one not find in a set collection, so it will not perform that action. uh, this is the way of adding and removing the elements. Suppose we already seen the several methods, right? Is empty. What is the purpose of is empty? It has to check or return true or false, the set is empty or not. Like that clear, the clear method is for clear the entire set. That means empty set, you can make that into an empty set. Next, mm, contains, you can check a set contains an element or not. What are the methods you can use for the array list? You can use it here also. The all you can here use, but the difference is it will store the unique element, that it stores not unique elements. It will duplicates also allows. And also through the indexes you can't able to access. That is the only difference. Suppose you are intent to add the one collection into the set. Your intent to add one collection into the set. Then set dot add all. We already seen that add all methods, right? Add all and remove all. Some collection of elements you are intent to remove, then remove all. Some collection of elements you are intent to add all. We already seen in the array list. Those are the all the methods are the same. How can you traverse in a set? How can you traverse in a set? We already seen the three types of traverses. One was through the index based, and through element based, and through iterator. Here we can traverse through in a two ways only. Why? Because through indexes I can't able to do, right. Size method is also there. It will return the how many elements in the set. Size is also a method. It will return the length of the set. uh, Two ways here we have to traverse. One was through the elements, another one through as a iterator. There are the only two ways you can traverse in a set. Index based traverser is not possible. Why? Because it not possible means you can't able to get it right. Why? Because it will not stores in a order, so you are not able to do it. Right. Okay. Once I'll check what will be the, suppose it's out of set dot get of 0, then it will throws an error. Why? Because set dot get method is not allowed. Why? Because we already know that it will not stores in a order, so you are not able to through the index based things. How can you traverse is first thing. For loop, all are the strings, right? So string yes colon through the for each loop. My collection set, then you can print simply sys out of yes, right. Another way for, sorry, another way through iterator, through iterator. My iterator contains the strings. Why? Because I am storing only the string types. It equals to set dot iterator, right. How can you traverse? While of it dot has next, it will check the next element exists or not, and sys out of it dot next, it will for printing the element, right. Fine. These are the two ways of approach. These are the two ways of approach you can traverse to the sets. Why you are traverse to the sets is, suppose you want to check an element exists in that node, you can simply a contains method is there. By internally contains method also do the traversal only, right. Then you have to know the thing. This is the two ways of traversing in a set. This is simply about the set. In the hash set, what are the methods you can use? Different methods contain such as that was size of method, remove all method, add all method, clear method, contains method. Several methods you can use. What are the methods you can use for the array list and all the things you can do it. But we have to focus on what are the things, the difference between the existing ones. We already discussed that add method, right. And size also we declare, right, right. Suppose when the scenario is suppose what will be the case, you have to store the only unique things. Suppose maintaining a website, you are have to store only unique usernames, right. Unique usernames and also unique emails, unique usernames and unique emails. Passwords will be the maybe a different and same number, but usernames will be the unique things entirely. And also when dealing with the banking systems, account number will be the unique for the entire bank data in the world or in the country based on the company size. Okay. And what are the different methods contains, right. In the tree set there are some different methods, so we'll check with the tree set what are the different methods we have. I'll do one thing for a while. Okay, I'll make this into a set. Okay, I'll make this into a set. Then I don't need it because I want to show something. Tree set have the methods of some methods contains first, last and methods. First, last methods are nothing but it will return the largest element and the smallest elements. Suppose if I print sys out of set, already we will do it, right. Sys out of set dot first. mm, think first, last. Set dot first not contains is empty, is method, add all, clear, get, notify all, parallel tree, remove all, remove if, retain all, size, split iterator, stream, to array, to string, wait. No, first not contains, I think. Advanced. In a way, you can go with the like this also, preset, everything for the linked hash set and the hash set and the things. Okay, right. Hmm. Now it will come. Set dot first. In before set it will be under the set interface. Now it will be in the this one, right? So set dot first, it will return the first element of a set. That means the smallest element in your set. Why it will be the smallest element? Means your tree set always stores the elements in a sorted order, right? So because of that, then it will be written the first element means the smallest element. Last means last. Last means greatest element. First means smallest element. Last means greatest element. And greatest element is mango. Suppose in a case, I'll store the integers. I can store the doubles also, right? Double, 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 right? And I can pass the values. 10.1, okay, and 9.1 and 5.5, right? And removal of 4, fine. Next here I can go with the last means it always gives the highest, right? So highest of 6.1, highest, okay, higher 6.1, okay. So nothing will be changed. I am changed the double type of the tree set and also inserting the some double values and try to removing that. And Java class lang dot integer, where it will comes the error. I think remove of for integer compared to the integer dot java, fine. 4.3, right? Then higher of 6.1, what will be print? 9.1. That means the next element which was greater than the your provided one, which was next greater. That means 6.1 greater than 10.1, also greater than the 6.1, but next greater to the current element, higher. And also the lower the same. These are the some different methods with the tree set, higher and the lower. That means you can comparing with the one number, okay. This about the tree set. This is all about the simply sets. You can change one data type to the other data type also by using the typecasting. That means one list into the set